Good morning, students. In the last class, we have learned about binary addition. Now, in this session, we are going to learn about binary subtraction. So, what is binary subtraction? Can you subtract binary numbers? Yes, of course. The answer is yes. Subtraction of binary numbers is an arithmetic operation very similar to the subtraction of decimal numbers or base 10 numbers. For example, 1 plus 1 plus 1 equal to 3. We know that in base 10. And 1 plus 1 plus 1 equal to 1, 1 in binary number system. When you add and subtract binary numbers, you need to be careful. As we see the rules of binary addition, we should be careful when borrowing as these will take place more often. So when you subtract several columns of binary digits, you must take into account the borrowing. It is 1. When 1 is to be subtracted from 0, the result is 1, where 1 is borrowed from the next higher order bit or digit. So students, binary subtraction is one of the 4 binary operations where we perform the subtraction method for 2 binary numbers. You know, binary numbers means it contains only digits 0 and 1. This operation is similar to the basic arithmetic subtraction performed on decimal numbers in maths. Hence, when we subtract 1's from 0, we need to borrow 1 from the next higher order digit. When we subtract 1 from 0, we need to borrow 1 from the next higher order digit to reduce the digit by 1, and the remainder left here is also 1. I shall make it clear with some rules for subtraction. As we have seen the rules for binary addition, similar to that there are some rules for performing binary subtraction also. See, when we subtract 0 from 0, the result will be 0. You know that when we subtract 0 from 0, the result will be 0. We get the answer as 0. And when we subtract 0 from 1, 1 minus 0, that means 1 minus 0, the result is 1. You know these two things, you are clear with that, I know. So 0 minus 0 gets 0, and 1 minus 0, the result is 1. When we subtract 1 from 0, that is when 1 is subtracted from 0, we get the result as 1 with a borrow 1 from the next higher order digit. So 0 minus 1 gives the result as 1 with the condition that we borrow 1 from the next higher order digit. And 1 minus 1 gives 0. So, let's remember that 0 minus 0 is 0. 1 minus 0 is 1. 0 minus 1 gives the result as 1 with a borrow from the next higher order digit. And 1 minus 1 equal to 0. So, note that the addition of two binary number 1 and 1 is 1, 0. As we have learned in the binary addition class, the addition of two binary number 1 and 1 is 1, 0. Where we consider 0 and carry forward 1 to the next higher order. 1 plus 1 gives 1, 0 with a carryover of 1 to the next higher order. But in case of subtraction of 1 and 1, the answer is equal to 0 and nothing is carried forward. In case of decimal subtraction, when 1 is subtracted from 0, then we borrow 1 from next preceding number and make it 1 0. And after subtraction, it results in 9. That is 10 minus 1 equal to 9. But for binary subtraction, it results in 1 only. So this is the difference. So once again, we shall rewind the binary subtraction rules. 0 minus 0 gives 0. 1 minus 0 gives 1. And the point to remember is 0 minus 1 gives the result as 1 with a borrow from next higher order digit. 1 minus 1 equal to 0. Let's remember this. To perform any binary subtraction with binary numbers, we have to keep in mind these rules for binary subtraction. Now it will be clear with an example. So let's see the procedure to do binary subtraction with an example. So here two numbers are given, that is 1 0 1 0 minus 1 0 1. Let's subtract 1 0 1 from 1 0 1 0. So the procedure to do the binary subtraction is, in the first step, first consider the 1's column and subtract the 1's column. Here our 1's column contains 0 minus 1. You know 0 minus 1 gives the result 1 as per the condition, that is as per the rules of binary subtraction. 0 minus 1 gives 1 with a borrow of 1 from the tens place. So after borrowing 1 from the tens column, the value of 1 in the tens column is changed into value 0. So here first 0 minus 1 gives the result as 1, and we borrow 1 from the next higher order digit. We borrow 1 from the next higher order digit, and when we subtract 0 minus 1, it gives the result as 1, but we have 1 borrow and we borrow it from the next higher order digit. So in the next tens column, the value is changed to 0 instead of 1. The value will be changed to 0. So going on to the third step. So subtract the value in the tens place. In the tens place, as I have said earlier, now the tens place have changed to 0. So 0 minus 0 gives 0. Now 0 minus 0 gives 0. Now again on the fourth step, now subtract the values in hundreds place. In the hundreds place, borrow 1 from the thousands place, that is 0 minus 1 equal to 1. So the result of the subtraction operation is 0 1 0 1. In this slide, I think some digits have changed. So listen carefully. If in this case our resultant of subtraction operation is 0 1 0 1, when you cross check the binary subtraction result value with the decimal value, the result value should be the same. The binary value 1010 is equal to the decimal value 10, and 101 is equivalent to 5. So 10 minus 5 equal to 10 minus 5 equal to 5. Therefore the decimal number 5 is equal to the binary number 0101. Now the next one is binary subtraction using 1's complement. The number 0 represents the positive sign. The number 1 here represents the negative sign. While performing binary subtraction using 1's complement, the number 0 represents the positive sign, the number 1 represents the negative sign. So the procedures for performing the binary subtraction using 1's complement are: first, write the 1's complement of the subtrahend. While performing binary subtraction by 1's complement, we have to change the subtrahend to its 1's complement. So write the 1's complement of the subtrahend. That's the first step. And in the second step, add the 1's complement subtrahend with the minuend. So remember, the first step of binary subtraction using 1's complement is to write the 1's complement of the subtrahend. Then on the second step, we have to add the 1's complement subtrahend with the minuend. Instead of performing subtraction, here we are taking the 1's complement of the subtrahend and then adding the 1's complement subtrahend with the minuend. If the result has a carryover, then add that carryover in the least significant bit. Remember, after performing the binary addition of the 1's complement subtrahend and minuend, if there is a carryover, then add that carryover in the least significant bit. If there is no carryover, then take 1's complement of the resultant and it is the negative number. So there are 4 steps to remember while performing binary subtraction using 1's complement. First, write the 1's complement of the subtrahend. Then add the 1's complement subtrahend with the minuend. And if the result has a carryover, then add that carryover in the least significant bit. And if there is no carryover, then take the 1's complement of the result and it is negative number. Okay, let's make it clear with an example. So our first question is 1 1 0 1 0 1 base 2 minus 1 0 0 1 0 1 base 2. Now, as per our rules, we know the solution is 1 1 0 1 0 1 base 2 is equivalent to 53 base 10 in decimal, and 1 0 0 1 0 1 base 2 equal to 37 base 10 in decimal. Now, taking the 1's complement of the subtrahend and adding it with the minuend. As per the rules for performing binary subtraction using 1's complement, we have to take the 1's complement of the subtrahend. 1's complement of the subtrahend, that is 1 0 0 1 0 1 becomes 0 1 1 0 1 0. You know, 1's complement of the subtrahend is 0 1 1 0 1 0. Now, after taking the 1's complement of the subtrahend, we have to add the subtrahend with the minuend. So, adding the 1's complement of the subtrahend with the minuend, we will get first on the most right hand side 1 plus 0. Of course, you know 1 plus 0 is 1, and 0 plus 1 gives 1. Then 1 plus 0, again it will be 1, and 0 plus 1, 1. The next side is 1 plus 1. 1 plus 1 gives 1 0 as result. Binary addition. In binary addition, 1 plus 1 gives 1 0 as the result. So we can write the 1 as the result and 0 as the result and 1 as the carry. So here we have a carryover of 1. And the next step also 1 plus 1 gives 1 0. So again we have to write 0 as the result and with 1 carryover. Now see, the result of this addition is 0 0 1 1 1 1 with a carryover. In the rules, as per the rules of performing binary subtraction with 1's complement, we have to add the 1 carryover to the least significant bit. Now adding the carryover 1 to the least significant bit, we will get 1 plus 1 equal to again 1 0, and we have written the 0 as the result and 1 carryover again. On the next tens place also 1 plus 1 carryover results in 1 0, 0 again as the result and 1 carryover. The next step also 1 plus 1 carryover results in 1 0, 0 as the result and 1 carryover. Again 1 plus 1 carryover results in 0 and 1 carryover, and on the next place 0 plus 1, it results in the value 1, and of course there is only 0 left with the other place, so we can write the 0 on the leftmost side. So the solution is 0 1 0 0 0. So this is the binary subtraction using 1's complement. As we had a carryover as the result, we added that carryover to the least significant bit. So I hope you got it well. So learn well. Thank you.